Okay, we're back. So I would like to bring in Karolina to introduce Dr. Schiffman, Susan Schiffman. Karolina, you're up.
Yes, hello everyone. I would like to very warmly welcome.
And please spotlight her. There she is. Okay, good.
Welcome Dr. Susan Schiffman from Department of Electrical and Computer Engineering at North Carolina State University. She's an expert in olfaction, medical neuroscience, and neurobiology, and she will talk, and her title of her talk is ENOS Technology, the Beginning. Dr. Schiffman, the stage is yours.
All right, this is ENOS instrumentation, the beginning, as I remember it. The concept began independently in two places. Once was with the US military in the US and also at the University of Warwick in the UK. The driver in the US was this man on the left, Dr. Dravniaks. He was born in Leningrad. He had a master's from Latvia in the University of Latvia, a PhD in physical chemistry from IIT in Chicago. And he had a paper in 1965 called Polar Vapor Detector Based on Thermal Modulation of Contact Potential. And there were several other people who had some early devices, but what Dr. Dravniaks was most known for was the human test tube, okay? And this is relevant to what we were just talking about in introduction. He put people into a test tube and he collected the air, and then he put the air sample into a gas chromatograph, which separates out the various volatiles and got a pattern. And he could then tell something about that person. When I asked Andy Dravniaks, why did you do this? This was a military project. He says, when you catch a spy, you need to know where they came from and what they've been eating. Here's another picture of that heavy walled cylinder. It was Pyrex. The samples were taken from that and then analyzed by gas chromatography. And GCMS was developed, GC was developed by James and Martin in 1952. So this took place around the middle 1960s. Also during that time, there was a lot of work being done on individual sensors to detect certain compounds. And one of those was ammonia. And the reason for ammonia was that you could detect troops in the jungle from the ammonia from the sweat and the urine. And when you combine ammonia with hydrogen chloride, you get ammonium chloride. And so that was one of the mechanisms for the ammonia detector. And there were also devices called the olfactronic palm detector, which was used to sniff out explosives and IEDs. This was the problem for the military in Vietnam, which was the Vietnam War was 61 to 75. And the Viet Cong dug tunnels underground, and they wanted to be able to detect these along with landmines and IEDs. Also at that time, there were some solid state temperature devices that were emerging to detect the Viet Cong. But the first time I remember the word artificial nose being used was Herberhold had a paper in biomedical engineering in 1971. There were a lot of compound-specific sensors. I worked on some of these projects early on, and there were hydrogen sulfide detectors. They were for individual compounds, but not the whole mixture. But there were a lot of problems of sensitivity, specificity, drift, deterioration over time, temperature problems, humidity problems. And I thought that the solution might be in the biological end, or biochemical end. So I took a year off and went to the UK to work on these. But at that time, I met Dr. George Dodd. George Dodd was a really brilliant Irishman who had his DPhil from the same lab I was working in. And this is a picture of him as I knew him. And he and his wonderful student, Krishna Prasad, had the first intelligent ENOS, and that was in 1982. That was published in Nature, and it was a commercial. It was used to simple commercial gas sensors. They were semiconductor materials, and they had different relative sensitivities. And the pattern of a response across these denoted the odor. And there were other metal semiconductor materials that were used in other equipment in Japan and in France, especially. This is a picture of George, the perfumer. He left the University of Warwick. He was a brilliant biochemist. He left in 1990 and became a perfumer, and this is him in his later years. Here's a picture of Krishna. He was an upstanding scientist here. He is a professor at University of Manchester and founder of numerous ENO systems. He's now founder of Multi-Sensor Systems. From 82 to about 210, there were lots of new sensory types, polymers, quartz microbalances, and a symposium was developed, the ISOEN, the International Symposium on Olfaction and Electronic Nose. It now meets every 2 years. It began in Toulouse in 1994. It's going to be in Portugal in 2022. Where are we today? Well, there are 5 of us that just published an article called Olfaction in the Artificial Olfaction in the 21st Century. It covers some of the early history, but also where are we going in 50 years from now? And there's also a group of us working on standards with IEEE, looking at standards for performance, and so that we don't have all those problems of drift and lack of accuracy. I hope I got in my 5 minutes.
You are amazing. That was perfect. I learned so much, and I have to say I'm a little bit embarrassed that I didn't know some of these things. I had no idea that we're doing this in Vietnam. I do know there was a report by the American military, I forget which branch now, that I actually have, that concluded with the idea that olfactory weapons themselves should not be used and should not be developed because of the loss of control. They had developed some odorants that were specifically made to terrorize the troops of the enemy and make them lose their minds, specifically due to terror. And in fact, I tried one of those odorants in my lab, and I knew it was specifically meant to trigger my fear response. So I held it up very far away under a hood, and I opened it very carefully. And I took, as soon as I got the whiff of it, it took every molecule of my being to not throw this thing away and run away. And for the half a second that I smelled it, it smelled, the images that came into my head were dinosaurs, big teeth, and for some reason, diesel fuel and poop all together into this horrific thing. But thank you so very much, Dr. Schiffman. That was amazing. I hope you can stay at the end for some Q&A. Our next speaker is Mike McGinley. And him and his father are, almost legends in the olfactory community. And I really want to hear what he has to say about artificial intelligence and his work. And I was really thankful to their company, who loaned me a device called the Nasal Ranger, which is a camera for your nose. I wish I had one. Maybe they will show you one. It really goes up your nose, and you can use it as a camera to quantify the intensity of sense. Mike, take it away. Fine.
I really appreciate being involved in this presentation. I come at this from the sensory perception side. St. Croix Sensory is specialized in odor perception using trained odor panels. My parents started the business 40 years ago. And a funny side note of coincidence that I did my graduate school work at Johns Hopkins University, and in my cohort was Susan Schiffman's daughter. And we got to sit and laugh about how doesn't everybody have an olfactometer in their house? Kind of unique and rare when there was 6 of us in the cohort, and lo and behold, there we were together. But we cover all different aspects of doing odor assessment. We do delve into a bit of food and beverage. And, this is the beginnings of an olfactometer in the early 80s, the Drevniak, designed and developed at the Illinois Institute of Technology Research Institute. And then we've grown and developed from there. This is a photo of our olfactometry lab space with assessors waiting their turn to sniff and observe odors at the olfactometers. There's a close-up of our olfactometer we developed in the late 1990s, podium style.
Maybe scroll down a bit. We can see the little...
The slides aren't moving.
Yeah, they're not moving.
Yeah, I'm trying to, I don't know why it won't let me go into presentation.
Yeah, if you can just scroll down on the left or make that window, we'll be able to see it.
I guess I don't know if I'm not seeing what you're seeing.
We still just see your initial slide. If you click on the PowerPoint, because you're probably still selected in Zoom. Just click on your PowerPoint, and then you should have control of it again.
Yeah, I'm trying, and it's not. Let me do a stop share real quick. I don't know. I'm really sorry.
No problem. We're used
I
to
do
it.
this all the time without a problem, and something's not.
It's normal for Zoom times. This is COVID times, so we'll learn to deal with it. I've had my kids walk in on all sorts of lectures and things, and it's never pleasant, but it's never great, but it's to be expected at this point. Technology is failing us all the time.
Okay, I think we're gonna get it this time here. Let's see. It's the share. Here we go.
Beautiful. Now you have it, so you can we can see your olfactometers. Wonderful.
Okay,
Right
now you're seeing that?
Yes, it's
Yes, we
beautiful.
are. Thank
Awesome.
you.
Apologize for that slowness. So that is our olfactometer we developed in the late 1990s. This is a newer olfactometer from Olfasense in Germany. This is, booth style, multiple assessors sniffing at a single time. That has been, a common methodology in Europe. We're doing all kinds of different odor assessment of not only on the environmental air side of things with nuisance odors, but we are sniffing, plastics from the automotive industry, coatings and paints. In large chambers, we do malodor reduction studies, cat litter and other things. And then quite a bit happening in the textile world. Here showing a picture of assessors sniffing from a chamber, making their assessments. And the classic type of photos that, this is quite recent. And, I have a group of assessors that do deodorant assessment that still at this point is the best option of determining differences in those products. And again, we cover a wide range of things. I'm doing so much with cats. I'm drawing up a design of a cattery to figure out how we can access more cat urine and the other things we do around here of our smell testing. Another fun thing was we do art and design, olfactometry, art and design, where we look at helping art groups put smell into theatrical presentations or different art installations. And it's been fun to take our experience of perception and what we've learned there and help apply that into these different ways of creating immersive environments and things. And it's a lot of fun. And again, our position is we're on the right there. We're focused on the odor perception side. And there's that connection to the odorants and, how we draw those connections. Our odor parameters, we assess odor threshold, characterization, overall intensity. From environmental odors, what we're looking at is how's that odor flow downwind? How does that affect the community? And we're able to help quantify what is happening in that situation. And that's where, our nasal ranger comes into play. So the nasal ranger is also able to go out and quantify odor assessment. It's a small dilution device, handheld dilution device. So you're able to monitor odor and quantify it based on dilution. And you can see here at the front of the device, there's different size orifices that help you dial in different levels of dilution. And the circles on the side are carbon filtered air to create that dilution air. So very unique and interesting and a common methodology, especially in the nuisance odor area of assessing odor. So it too is able to go out and measure what's happening in the community to put quantified values to that. Now, threshold's only part of the story. The dilution is only part of the story. We also look at intensity and character. Our assessors are doing odor profiling. And then we also look at things like Weber-Fechner relationships, Stevens power law relationships, and looking at intensity with dilution, but also looking at character with dilution. And so how does the perceived odor change with different levels of compounds being present? This just showing very simple graphic, so to speak, of different samples that being assessed. These are, different replicates mixed in here, and really seeing with the human assessors, you can get this repeatability, but fully acknowledging that the eNose or sensor technology, a next level of being able to take readings more quickly, more frequently without pulling panels together. But a key part being drawing that connection of the perception side to the analysis side. And so that's where we see our role as we're doing more work with things like SIFT-MS and GC olfactometry, and what are ways to link the molecular side with the perception side. So sorry for my slow start, and I'll be around for the panel discussion.
That's great. We have some people raising hands, but Karolina will introduce the next speaker. That was fantastic. Thank you. Thank you, Mike.
Yes, thank you, Michael, so much. The next speaker that we are going to hear from is Professor Dr. Inger Leemans from Royal Netherlands Academy of Arts and Sciences. And she's also part of Old Europe, which is like organization founded in 2020, asking questions: how should we safeguard our olfactory heritage, and how can we extract sensory data from large-scale digital text and image collections, and why should we? The title of her presentation is Olfactory Heritage and Sensory Mining. So I warmly welcome Professor Dr. Inger Leemans. Hello.
Hello, thank you very much for that introduction, and it's really wonderful to be here. So thanks for inviting me and giving me the chance to present Ode Europa indeed. Ode Europa is a new project we started in January of this year with a group of 7 different research groups, also different disciplines together indeed. And what we want to do is to create AI technology in order to capture information about scent in digital text and digital images collections, and to interpret those into storylines. So what were the important scents and scent narratives and sensations and perceptions of the past, and then reconstruct those and bring those back to the public nose at this moment, and also to think about what is the importance of olfactory heritage, right, of our olfactory practices and perceptions. So the way we do that, we have an image recognition group, for instance, diving into think about old paintings that have been digitized all over Europe. We have a text mining group. What they are going to capture is going to be combined by the semantic web group, classified, ordered, and then interpreted by a group of historians. We also have an olfactory heritage science group trying to capture think about historical objects that still have scents, like old perfume bottles, to capture the sense of that, and think about how we can digitize and also document different or the information about the sense of the past. And then, as I said, we're also going to develop olfactory events and olfactory tours in different cities and locations in Europe. Now, maybe just very shortly, because as I said, we just started, so a lot is in development. We're now trying to build a model that can find, for instance, olfactory objects, but also olfactory gestures like pinching the nose. Actually, we're tagging dogs at this moment and to see what dogs are sniffing in paintings. We're thinking about fragrant places. What were the fragrant spaces of the past? In the text mining group, so I was really happy with Anne Barwich's plea for please try to also think about how to capture human perception and not only think in molecules and descriptors, but also what are the evaluations that are given by people when they are describing text of olfactory information. So we're actually at this moment trying to mine 7 different languages from a couple of ages. So we start in 1600 up until the beginning of the 20th century and try to see how we can translate all those different vocabularies and compare them with each other. So that's quite a challenge. And like I said, the semantic web team is trying to build an ontology to that can order the information that we find. I'm describing this in layman's terms at this moment, but it will be a model that can be or a knowledge graph that then can be populated by the extracted information from the text and image collections. And this is just an example of part of the model that we're building now, because a lot of this in century mining is quite, we're really pioneering here. We don't have descriptions to use for a lot of the olfactory heritage issues that we're looking at. So our group needs to find ways to model that information. And the same is to think about the documentation of heritage scents. Where are they captured? How can we describe them? How can we recreate and reconstruct them? So that might, I hope, in the end, deliver a lot of information that can be distributed amongst different groups. We were amazed by the interest for the history of smell, actually, when we started to communicate about our project. So that was marvelous to see how much this topic resonates also with the larger public, actually all over the globe. So if you want to know more, then this is the information about our website, and you can join our network so we can keep you updated about what we are developing. Thanks. Is that 5 minutes?
Yes, that was fantastic, and thank you again. I learned so much. I would love to join you. I'm enthralled. If you can stay for the Q&A.
Yeah, sure.
Okay. So next, I'd like to introduce Pat Moran, who should be getting ready. And well, Pat, I'll share my screen again to tell you the story here for a second only.
Hey, Andreas, can you hear me?
Yes, we can hear you. You're almost up. So, but I want to introduce you for a second there. Pat is behind the electronics in my nose, the nano nose, which is, I'm showing a picture here. I believe you can see it. This is about 1.5 feet across. It's very, very heavy. It was made to look bulletproof. It isn't actually bulletproof. It was made, the box was made by Scott Lefton, another fantastic designer and mechanical engineer. Pat is an electrical engineer. He has been with a contractor from MIT, and I am so pleased to have him also as a co-founder of a startup that has nothing to noses, but eventually one day we'll be able to put noses everywhere, so he will. And this nose was the first nose. This went to DARPA. I'll talk about it at length. And Pat has been busy since then shrinking it with me, and he has shrunk it to something like this via various iterations. And he'll talk to us about the challenges of creating these kind of devices. So Pat, you're up, and take it away. 5 minutes. Thank you.
What I'm going to be talking about is how we got to a system that we think is pretty good for detecting odorants in various situations. We ended up with this device here, which is a very small, compact sensing device that uses micro IDAs. Perhaps that's not focusing, but there's more pictures later. So one of the things we found out, oh, thank you, Andreas. One of the things we know is that we have many sensors that we can use on the market. And there is potentially a lot of variations on what we can do with them and where we can implement them. How small are they? How costly are they? What kind of signal processing is available? So we started looking at, what does a dog actually do when it's sniffing something? I have a little video here. I hope it'll work. It's an image of, can you guys see this?
No, we cannot. Zoom is currently only sharing your PowerPoint.
Okay. Let me stop this and okay. Let me see if I can share.
Yeah, that works. We can see it quite well. You can scroll through there. If the full screen stops everything from working, we can see it quite well here.
Yep, I'm just going to go ahead and do a new share, and I'm going to share my screen instead. And I'm going to go to this and go back to this. And hopefully the video will show now.
Yes, it does.
Okay, so this is my dog, which is a red bone coonhound, and he is running a scan for scent right here. And his thought bubbles are popping up on the screen, but one of the things that's interesting about this, of course, is that he's smelling things, but he's also processing data from many, many inputs. He's smelling the ground. He's checking his database. He's doing some identification of scents. One of the things in here that you'll see is that he eventually finds something and turns around. Here he's fast forwarding. Not too interested in what he's seeing now, but he turns around and looks back to see what it was that he just ran into. So this was a motivation for understanding how we can put the system together that recycles the data and recycles the odorants, so that there is a second pass once you understand what can possibly be, what the domain of the scent is. So in this case, you'll see that here he's resetting his scanner there and he's starting over. So when we put the system together, we incorporated the sensing device into a recurrent detection probe. And I'm going to fast forward this a bit. So this is him backtracking over what he saw and seeing his scent, and then he finally at the end here identifies something and lets out a bark. So that's the living manifestation of a odor detection machine. So going back to the slides then, so we have these sensors. What do we do with them? Well, we concentrate on the electrochemical resistance and conductance with potentiostat. And this is what the potentiostat basically looks like. We have the sensor here, and then we have this surrounding electronic signal processing system that very oversimplified. There's lots of different things, as was mentioned before. There's a lot of drift. There's a lot of range and resolution issues, and those are all need to be accounted for in the system. So the glue that hangs around this is really quite important, and probably more so than the actual circuit itself. But the idea is that you apply a voltage and you measure the current, and you have a chemo sensor here with a activation material on it, and it then produces some kind of a voltage in this case. So what are the kinds of things that are needed for the system? Well, this is a recurrent neural net gate, and the sensor in this case are the delta sigmoid transition blocks. So each of these devices is essentially one of these blocks in here, and with our large system of components, we can chain them together and reformulate the bias and the range and resolution on the fly, either in parallel or in series, which allows the detection to proceed downstream to an AI system. So the AI systems are developed elsewhere, but the hardware and components are developed here, and there's a lot more work to do, a lot more concepts, So what I can say is that there are still many pathways ahead. And if you'd like help in understanding how to do that, or miniaturizing, or building a system that can do this, you can contact me here. So thanks again, Andreas. And
thank you, Pat. That was great. I think there's indeed, please stay for the Q&A. People who have questions. Karolina, you're up next, introducing the next speaker.
Yes, hello. So next speaker is Matthew Waldman from Keio University. And he's like connecting with us from Thailand. So there's like a very, if I remember correctly, not from Japan this time, but from Thailand. So there's like a big time event. So thank you for being with us.
Thank you for having me. This is super interesting. Yeah.
That's good to hear. So Matthew is a designer, inventor, and educator. And he has like over 30 years of interdisciplinary design experience.
Mm-hmm.
And he and you describe yourself as techno-progressive human being.
Yeah.
So the title of your talk is Presence and Intention with Olfaction.
Yes. Well, I wanted to give a little bit of background first, where I started out not as an academic. I started out as a design entrepreneur, but a lot of my design work, I know I'm not supposed to pat myself on the back, but I've always been 10 years too early. I started an interactive design studio in 1995. So I never got the investment wave. I started doing embodied, trying to design for fashion tech in the early to mid 2000s. I tried to do smartwatches in 1999. I ended up creating a brand that was techno-progressivist to show that that people that at the time were considered geeks or nerds were not necessarily socially geeks or nerds, people like myself, and there weren't a lot of fashion choices. So what became a speculative design project became an actual fashion brand called Nuka that was quite popular from, I'd say, about 2004 till we went bankrupt in 2016. But when I did the brand, we started out with timepieces. The intention was watches, but the concept was universal language. How do you communicate complex concepts universally? So let me just share some of that work first, because that'll give some good context. Can everyone see this presentation?
Yes, we can.
Okay, awesome. So let me go to full screen. So not to go too deep into it, it was basically to bring the revolution of interface design to physical objects. So how do you express math concepts with passive intelligent interfaces? And they became these line of interfaces for time telling, but the idea was never to create a watch company. Really, the idea was to communicate that my whole dream of the world of the future when I was a child was that we would be living in a world where we all spoke one language. And I think that scientific development, mutual development, especially when you see the environmental issues that we're having right now, that we're not on the same page, we're not sharing research, all these issues go back to language. And also design is very much tied to linguistics. So the concept of Nuka was to show people that we could have this conversation about universal language without arguing. I always had arguments with people saying, oh, well, there's a word in Italian that I don't have in English. And I would ask people, well, tell me that word. And they would tell me the word. And then I would say, okay, could you explain to me what it means? And they would explain to me what it means. And I would say, well, you just told me what that word means in English. So the concept is translatable. It's just not a single word. And I think this is still a really valid and important discussion to be having about universal language and monoculture, and not necessarily monopoly and people overpowering and whatnot. But I found that these discussions that need to happen are easier to have with design and with objects and with interfaces. So when people said, okay, so you're not a watch company, They were like, what's your next product going to be? And I started exploring what are these other ways that everyone here understands where I'm going with this. How do you, what are other ways that we communicate universally? Like what are things that might work on another planet or with aliens? And I thought, okay, well, scent. My next product's going to be a fragrance. And I said, if I could translate and also the thing about nuclear, I only have 5 minutes, is all about higher base mathematics, how we learn math as base 10, but time and geometry is base 12. And physicists like to use higher bases of math. So what everyone thinks is, also like geometry, Euclidean geometry doesn't really explain the world we live in, whereas Riemannian geometry does. So why aren't we learning Riemannian? I'm probably not pronouncing that correctly. Why are we not Riemannian or whatever in school? Why do they continue to teach us that Euclidean geometry is the geometry of our world? So I started really exploring all these, like, what is universal to the world we live in? And I came up with, for people, there's scent, and we communicate through smell. And so could I communicate the idea of techno-progressivism, that the future is still going to be sexy? Could I tell the story that I'm sorry, I'm just like, in the future, people are still going to be having sex. It's like, it's not going to be like all robots. Maybe it will be all robots, but I wanted to tell this story through scent instead of just through these other physical objects. So for that, I want to share a video. And someone is going to have to walk me through how you get the video from the web to play through the
perhaps Matt, if you just copy paste on YouTube, if you copy paste the URL, Matt will be able to show it to everyone.
What if it's Vimeo? Can you do it?
Is it
Sure,
on
as
YouTube?
long as it's public.
Yeah, it should be. Let's try that, because then you can play with
Copy
the
paste
sound.
the URL. Matt will put it. And wow, what a journey! I can't wait to ask you the question, which is what is the biggest difference between scent and how it's perceived in Japan versus how it's perceived in the Western world? But you can answer that afterwards.
Oh yeah, that's a very interesting thing, because Japan is the absolute worst market for fragrance. It's they just don't it doesn't sell because they don't like to bother other people. They don't want to impose their own scent profile on a stranger. So it is really interesting, but that's a nice discussion to have. But there are scents, like, for example, from country to country, like what's considered a clean scent is very different. So what I really love about Japanese soap products is they use the lotus flower as a main scent note, and that's what I'm used to as being clean. In Thailand now, and I had a really interesting, also back to linguistics, where the whole room smelled of cleaning products, and I was getting asthma. But when I said the room smells of cleaning products, they sent me more of the same cleaning products. So even though the staff spoke English, they hear the word smell, and they immediately thought it meant the way they learned English, that the word smell means bad. Like so I had to call a friend in Bangkok and had to translate. The smell of the cleaning products is giving me asthma. I need cleaning products with no fragrance. So anyway, that's like another story. But I just shared the Vimeo. If someone could play that, that would be great. Oh, did I share it in the right place? No, I didn't.
No, I don't see it anywhere.
Hold on. I should give it to Matthew, or
the chat.
You could just put it in the chat.
Put it in the chat for everyone to see. So while we're doing this, next will be Tristan Rousselle, and then after that we have Chris Rose presenting the ideas, and we'll have a little bit of break in the middle for some Q&A. And
yeah, I'm trying to get this all in 5 minutes. I have a small presentation as well.
Thank you. That was good. Oh, Vimeo. Okay, so Matthew, you'll play it. I mean, sorry, Matt will play it. Yes, here he is.
So that URL doesn't work anymore. The company, we went bankrupt. That's another longer story. But I worked with one of the top noses in the world. He's still one of the top noses. His name is Pierre Gueros. So he's in Paris. And he actually in interviews says that it was the most amazing scent he ever worked on. We got 4 stars from the New York Times. They don't give 4 stars to anything, but I couldn't sell it. But this is not a business conference, so I'm not going to talk about that problem. But the story that I wrote, the narrative that I wanted people to get out of that video and out of the scent itself was, I wrote a story about teenagers having sex in a forest. And I was a little more complicated and involved the story about like who was doing what to who. It was a very involved story on what types of trees and whatnot. And about discovery, about the couples finding their partners with different partners. So it was a very human teenage sex story, but with a lot of inferences of the forest, the mold of the soil, the dampness, the pine needles, the air, the ionization. And then I took that context and I said, but this forest is on a space station. So what does that smell like? What does teenage sex in a forest on a space station smell
Matthew,
like?
that's very interesting. We will wonder about that for the next few days, but I think we need to move to another speaker because
I love this. Please stay for the Q&A. I think we can finish it, but God is good.
Yes,
we don't want to lose our next presenter who might have to leave early.
Okay, I'll share the presentation in the chat if anyone
Please
wants
do.
to.
And wow, yes. Okay, so next is Tristan Rousselle. He's the founder and the deputy CEO of Aribel Technologies, and he has been to my lab, I think at least once, maybe more than that. And he, I think, also knows Shuguang Zhang, who is the reason I'm at MIT. And he's going to talk about peptides and silicon photonics and the universal representation of scent, which dovetails so well with Professor Waldman's presentation just now, and Professor Dr. Inger Leemans' presentation before. And this idea of representing perceptual space essentially is key to us understanding it. So Tristan, take it away.
Thank you very much, Andreas. So yes, I'm sharing my screen. Not easy to speak after Matthew, because indeed my presentation is going to be a bit more technical, but I hope I will allow everyone to follow. And again, this is a very inspiring conference, so thanks for inviting me. So I think you must see my screen now, but I will try to put it full screen. So you should see slide number 2, which records the simple, pre-simple on how electronic nodes work, right? The number 2, thanks. Okay. And so simply, yes, trying to use different receptors in parallel to generate some useful information. So on this slide, there is a little device. There is an image with black, white, and gray dots. Sensogram that is quite abstract, but still let us understand how the volatile molecules generate a signal on the sensor. It's quite classic to use radar chart to present smells. So of course, with different radar chart associated to different smells. Okay, so this is the principle. Eventually, this can be very fast. So at Aribel, we are using technology that generate signatures in less than a few seconds. Sometimes it's a bit longer. It's also a matter on how often you can analyze different smells or see the evolution of smell over time. So, but what I wanted to talk about today is how we came up by choosing the receptor, the transducer, and so different types of representation. So for me, actually, it indeed started quite a while ago in 2013 when I met Shuguang and Andreas in their labs. I was actually just finishing a first entrepreneurial project, biotech project, recognized as an expert in biotechnology and protein chemistry. And they presented me their work on olfactory receptor adapted to the analysis of smells. So people who were helping me there at the MIT were telling me, well, you're going to use this to screen molecules, right? And that's eventually for drug design. But I said, no, I want to change a bit subjects, and I've done it. I've had enough of pharmaceutical companies who were my previous clients, And I was very inspired by the possibility to use those biotech tools, molecule-molecule interaction tools, to go outside medical diagnostic and to eventually switch to the full universe of smell analysis. So, but my personal opinion was that playing with olfactory receptor was going to be quite tough. And so I decided with other scientists I knew here at the CEA and CNRS in France to choose another type of biochemical compounds, smaller molecules, namely peptides, and this for different reasons. First, they should work directly in gas, which is not the case for proteins who need liquid environment, especially if they are small and therefore cheap. Of course, peptides based on amino acids have very huge chemical diversity. So eventually, they will allow to differentiate different types of smells. There are different binding properties that are known, and that's very important for the follow-up. And they can easily be grafted on surfaces. So plus, quite soon came the idea that if we understand well the binding between volatile compounds and peptides, we could also generate a model, and that this model could be used in the future to suggest new peptides, because the diversity is so huge that you have to use modeling to actually choose the best peptide. Well, it happens that by the end we chose a first set of 20 very simple peptides, and that we still use them. We are just starting modeling to eventually enhance, improve the properties of our technology. I also want to refer to the meeting of Cicel Tolas. I think she's going to present tomorrow. She helped us from the foundation of the company, and she's been very inspiring in helping us out to imagine how we could represent smell, right? Because smell data representation is definitely not an easy task. So after our first development, which was based on surface plasmon resonance, we chose another transducer, a Mach-Zehnder interferometer, which happened to be manufactured at wafer level. So it's derived from silicon photonics. It can be manufactured in parallel. It's very small, it's quite cheap. So you see those Mach-Zehnder with reference arms and of course the active arms. And those little dots, droplets actually, are the droplets full of peptides that showing how we graft the peptides on the MZI, on the chip, okay? So this is with 16, but now we have a version with 64 MZI in parallel, and happen to be a very powerful tool. It's not extremely sensitive, but since it can be manufactured in parallel, it's actually a quite interesting choice. We tested others, but definitely that has been our best choice. So then comes the analysis of those patterns, those signatures. Never easy, very abstract. You always have to compare, generate a database of reference, compare to a reference to say if it's the right order or not. So, but yes, we had to deal with this. And so we did indeed develop the software. What I wanted to insist on is that, of course, you have to do co-development of hardware and software to make this work. And knowing that the first user would be engineer, scientist, it was okay to make quite complex and abstract mathematical representations such as a PCA, eventually showing the intensity, some classification score, as well as confusion matrices. Okay. In parallel, at Aribal, we have always been trying to actually present some very simple demo to show that we could also simplify the output and the representation of the results, such as the beef freshness index, cooking index, and also some demo to represent on a screen. This is actually a watch into which we were able to fit the sensor. So PCA, so very good tool, very used, but unfortunately, when you switch, this is the presentation where I just withdraw one molecule and it totally flipped the PCA. So for me, it was always a problem to see that we could not recognize the axes. They were always changing, so we had to find a way. So because we knew the properties of the peptide, we decided to project them into 2 axes. And so now we are able, it's very new. I'm just presenting this for the first time. So you see here, I just removed the same molecule and the axes don't change. So it's very simple. It's just a translation of some of the properties of the peptides. You can see here something that may help you. Van der Waals forces, isoelectric point. Yes, that was just a quick summary. I only had 5 minutes to actually present you the latest update on Ariba. I'm sorry for the technical problem.
Yeah,
thank you.
Thank you, Tristan. Please stay for the Q&A. That was supremely impressive. I cannot instill in the audience enough respect for you. You have to realize how sensitive Mach center interferometers are. And for Tristan to put 64 of them, did I hear that right? 64 in parallel. I'm very, very impressed. That is incredible. Okay, so for the panelists, please, if we can spot them now. We have a few minutes left for about 7 or 8 minutes for Q&A. And I'm going to look at, maybe Karolina also help me with picking up some of the questions that appeared in the chat. I hope all of the panelists are still here. And my chat has gone away, but I have some questions, but I'd like the audience to first tell us what they want. Can someone see the chat? My chat disappeared. If someone can read a question from the chat, if not, while this is happening, I don't know, Matt, what happened to my chat thing. I have various questions, including, well, maybe I'll throw it back to Prof. Waldman. He was about to talk to us a little bit more about techno-progressive and the sex in space and the smell of space. And I was hoping to hear if you have some, if you're still with us, if you have heard of this, that the smell of space is a thing. At first I thought, well, space is a vacuum, there'll be a smell. However, I've spoken to 2 astronauts now who report the same thing, that when they come back from an EVA, from an extravehicular activity, and they put their space suits back, and that, it was back when the shuttle was a thing, or sometimes they bring in a satellite and they repressurize, that they experience the smell of burning meat. And there's a big debate about whether it's real, whether it's truly that, whether it's their suits getting bombarded with gamma rays and cooking the leather in there, if there's leather, organic fibers, or whether it's the paint peeling off, or it's maybe something that is burned in their noses as a result of being out there. So I have no idea about this. So maybe, what does Prof. Waldman think about the smell of space?
Oh, I'm sure. I mean, I would love to go there and experience it myself. I'm sure that there has to be something with, the way the sense of taste, when you're in an airplane, the differences of air pressure and gravity affect the way a taste and smell is. So I think going between such extreme environments, there must be some kind of change that happens. If it smells like burning meat, that's quite interesting. But it's also on the space stations, it's not like there's no air up there either. There are volatile molecules. People, I was surprised when I worked on a speculative design project for the NASA toilet, that the biggest problem in the space station is not is actually people vomiting. So that was another thing that I didn't realize, that people, their stomachs are not very, you would think that I would think that urine was the biggest problem, but apparently vomit's the biggest problem. So yeah, it's interesting.
Yeah. And we have a question for Professor Dr. Inger Leemans, again about the perceptual space. You spoke of language as connecting our perceptions. And this question of, is scent universal? We know that different people with different genetic backgrounds have different receptors, similar to how vision is not universal. Some people are colorblind, some people are completely blind. What have you found that is truly universal in the language? And is there another way? Is there something beyond language? Is there something synesthetic? Professor Waldman wants to live in a world where we all speak the same language, and perhaps there is a way via scent. But what are the challenges? And somebody asked you if you've considered Sanskrit also, which would have, one would think that it would have a deep knowledge and deep vocabulary when it comes to scent.
Yeah. So it's quite a challenge already for 7 languages. We would love to do all, of course, but let's start with this and then see where that leads us. Universal, for me, it's very early to say, right? Because we're now comparing the way languages work in similar or dissimilar ways. maybe the volatility of smell language is what is universal. So if we see patterns over time, then there are so many changes between what words are used for either fragrant or malodors, and whether those valuations are either inherent in words or sort of branched out. So for me, it's really hard to already give an answer to this at this point in the project. What I really like about what we're finding already is the richness of the historical language. So, for instance, in my language, in the Dutch language, in the 17th and 18th century, we have such rich vocabularies, or we had such rich vocabularies, and also more precise vocabularies to describe a specific scents, like the scent of cellars, or I live in a very humid climate, so we had so many different words to describe that, and we lost that. So
That's
I
great.
hope to
Thank you.
tell more about later.
Yeah, so enlightening to think of it, and I think we should all consider how we speak of scent and how we have to always assign a name to it, and it's very, very difficult to communicate scent, and that's why it takes forever to become a perfumer or fragrance chemist. Now, Dr. Schiffman, there's a question for you too here. Someone asked if you know of any cases of reverse biomimicry. You put up this paper of Nature 1982 where somebody used the nose and they said, well, this is an analog to perhaps how the nose works, and but that was way before we actually knew about olfactory receptors. So the question is, do you know of any cases where people thought back and said, oh, this is how a machine nose works, maybe this is, because this happened with television. We knew how we created television before we understood how color vision works, but nobody asked the engineers. The biologists had to figure it out all on their own. If they had asked the electrical engineers, how did you build color TV, they would actually know how color vision works.
We all thought at the beginning, starting with Andy Drovniak, was many of our mentor. He was our mentor to many of us. We all thought it was a pattern. And this is really relevant to what Ingmar was just talking about, is that we thought it was a pattern. And so we didn't worry about language. I have a book called Introduction to Multidimensional Scaling, which will bore most of you. But what we do is we took the pattern across the people, how people rated them, and then we put things in a multidimensional space so that the orientation of the odor in the space gives you an idea about what the odor is. I have an article in Science in 1974 where most of you were not even born yet, but it shows what happens when you put odors in a space. They separate into two parts, good and bad, okay? And this is universal across all languages. A paramecium goes towards something, it goes back away from something. We're programmed that way, it's in our brain. So it's pattern. This was something that we thought from the very beginning, and it shows up in a space. If I ask you how far away is Chicago and San Francisco, or how far are each of these things, and you put them in a matrix, and then you take that matrix of similarities and put them in a map across cultures, you can then see how people view various kinds of odors.
That's fantastic. So do you have actually a recording of how the cities smell somehow?
I have papers on this. Just you know,
you should have
we avoided language at the very beginning because people I was working with were from all over the world, and we understood that we didn't understand each other. That there was no word for something in one language when there wasn't another.
Yeah,
Japanese. Very interested to comment on Japan from Matthew Waldman, because that was our one problem area.
Yeah, so that dovetails perfectly to. I'm sorry, Matthew, did you have something?
No, the way cities smell. It's there are a couple of perfumers that try to do these city scents, and they always try to paint some kind of like not a realistic story. You know, like it's Tokyo it's a volcanic country, so there is a sulfur smell that's probably people just ignore. It doesn't make a good fragrance. You know, New York in the summer smells like rotting garbage. I mean, there aren't that many big cities that have a really nice smell. Taipei to me smells like turpentine, you know? So I think that's a wonderful project. I'd really love to read more about it.
That dovetails perfectly to Mike McGinley. There's a question about What do you see as a sort of there's a two-parter. It's one is what do you see your technology, like the nasal ranger and others, as having most application now that people are sort of becoming sensitive to smell quite a bit? I heard that one of the concerns is that people are growing a lot of marijuana in their homes now, and the neighbors are complaining, and that's been used for legal. And the two part to this is, if and when we get to, not if, but when we get to everyone basically having a super nose in their phone, how are we going to educate the public as to how far your sense goes? You know this better than most people. Like, how far can somebody see me with a camera? You know, with a telephoto lens, it could be pretty far. How far does somebody's body odor can go before it gets mixed up with everybody else's and becomes unusable for mining?
Some good questions. The nasal ranger itself being used very routinely in nuisance odor assessment. I was just doing training last week at a state agency, and cannabis growing odors are, you know, the most common they're getting right now, but they still get complaints from pig farms and rendering and things that have been around for decades. So it still exists, but we had conversation last week during that training about how as other environmental aspects are improved, how then it makes people maybe more reactionary to even lighter odors. You know, does our nuisance threshold starts to drop? But all of this relates to, as Susan was just talking about, how bad is it? And the things that are universally bad versus things that, you know, to some people, maybe cannabis growing smells great, the terpenes and whatnot. But, you know, so there is some level of what is your opinion, what is your experience? But there's also the question of the unknown, and how do we then react because we don't know what we're smelling, or we're concerned if it's smelling, it's harming me. But yeah, and the throw of that smell, like how far will it go? Industries can throw it, you know, quarter mile, a mile away. Us as people, you know, I call it the pig pen effect. If you know, think of the Peanuts and, you know, the cartoon character with the cloud around him, and that's that, you know, how far does that body odor, you know, waft away from us before it dilutes?
Yeah, thank you. So I have one more question for Tristan, and the last question goes to Pat. And after that, we'll have a little break with maybe 5 minutes, and then Chris Rose will take over to do the ideathon, where everybody is invited to participate, ask questions, turn on their cameras, etc. But the question for Tristan is actually quite technical here. It says, are you actually using the peptides themselves? And for me, I have a comment. You said that proteins do not need liquid to be stabilized, which is true in nature, but we found remarkably so that you can actually stabilize them on top of chips and on top of possibly a microsender using Schulung's peptides and other things. And the most remarkable thing about it is, which still breaks my mind, is that even though this protein is a labile system that jiggles around in 37C mucus, after you squish it and you stuff it into a dry form, it still recognizes the same ligands, the same odorants, even to the same sensitivities, which, you know, it breaks all of lock and key and all these things that are in the textbook. So, so the question for you is, yes, tell us a little bit more about the peptides and the technology before we jump to the pack.
Yes. Well, yes, we are discovering this, right? And practically, experimentally, and indeed, we are playing a lot with variation of humidity. So because we see some properties that are enhanced in presence of high humidity. Some are kept even if it's dry. So I think there is still a lot of unknown, and it's true. And I know your work with Luca Turin, if I remember well. There may be other things, but you know, we cannot say too much. Not that I don't want to say, it's just that we don't know. It's true that we have a nice tool that may also allow to make progress on the understanding of olfaction. We'll see.
So that makes me to Pat, and for the last question of this session is, Pat, what do you see? You showed a lot of different types of technologies that are possible. What do you see as sort of the biggest obstacle to bringing this to the mass market? Is it cost? Is it because it doesn't seem to be still the primary sensing method? It seems like we're spoiled for choice when it comes to sensing gases. Why is it that we haven't got more of it? What do you think from your electronic standpoint?
Yeah, I think that the biggest issue is system integration with all the components, and putting an intelligent system around it that does some kind of blind identification in a way that doesn't go off into the weeds. Of course, miniaturization of the sensors and stuff is very important, and making them repeatable and reliable, but that can be dealt with. We've done that before. We've put in auto calibration, we put in time domain normalization, but it's really this cross-sectional component, whether it's our understanding of the language and what we mean by a smell, and what the mass spectrometers are saying, what the IR detectors are giving us, what the impedance is giving us on a surface. Putting that whole thing together is really where the problem is. And we have the technology now in a smartphone, but we don't have the software yet. So I think it's a software issue. That's really what I think.
Right. And that would go well with the perceptual parts of it, the language that we all speak. Are all the phones going to detect the same kind of smell and report it the same way, or are we going to have variations by country and by thing? Thank you all very, very much. It was a wonderful session. We apologize that you only had 5 minutes each. I hope you stick around for more during the ideathon. We're going to take a break now. Every question that has been submitted, we will share with the speakers. Some have been answered by others. It's been a very dynamic comment section here. I've got 3 screens here trying to manage it all. For the next, Matt, please put up one of the videos, perhaps the PCF one that goes for a minute, for everybody to take a break. And then I will throw it to Chris Rose, who will become the moderator and explain to us how Ideathon works. And I invite everyone back in a couple of minutes to participate and ask questions and create content that will be then highlighted on our page. It's a very dynamic conference. We're creating content that will be shown today and tomorrow we'll be creating content that will be shown on Saturday. So please come back. And thank you again to all the speakers. You have been fantastic. And thank you so much.